Hi, in this video, we will learn how to find equations of parallel and perpendicular line and how to solve any question related to these concepts. So let's start with parallel lines. So the diagram shows line L1 and there is a line L2 which is parallel to line L1 and passes through the point 3, 2. So you have a line L1 which has some gradient and has a y-intercept of 2. Y-intercept is the point at which the line intersects the y-axis. Since the line L1 intersects the y-axis at y equals 2, so the value of y-intercept is 2. Now, if I say that there is a line that is parallel to line L1, that means that particular line will have exactly the same gradient as line L1. For example, this blue line is parallel to line L1. That means this blue line will have exactly the same gradient or slope just like the line L1. But that parallel line can have different y-intercept. For example, this blue line which is parallel to line L1 has the y-intercept of 0. Now this has the y-intercept of -2, but it is still parallel to line L1. This has y-intercept of -3, but it is still parallel to line L1. Now the line L2 is parallel to line L1 and passes through the point 3, 2. To find the equation of line L2, what we can do is find the gradient of line L1, which will eventually give us the gradient of line L2. Gradient is change in y over change in x, or you can simply say y2 minus y1, difference in y coordinates, over x2 minus x1, that is difference in x coordinates. So to find the gradient, I'll choose two coordinates on the graph. The first one is 2, 5. And the second coordinate I'm choosing is -3, -2. So the gradient becomes y2 minus y1, 5 minus -2, divided by x2 minus x1. That is 2 minus -3. So the gradient becomes 5 minus -2, that is 5 plus 2, which is 7, divided by 2 minus -3, which is 2 plus 3, which is equal to 5. Now this is the gradient for line L1, which will be the gradient for line L2 as well. Now for the line L2, you'll have the equation y equals mx plus c, where m is the gradient and c is the y-intercept. Now the gradient for line L2 would be 7 over 5, just like line L1. So y equals 7 over 5 x plus c. Now to find the value of y-intercept for line L2, you need to use the coordinates 3, 2, since the line L2 is passing through the points 3, 2. So for y, I'll use 2. 2 equals 7 over 5, and for x, I'll use 3 plus c. So this becomes 2 equals 7 over 5 times 3, which is 21 over 5. So 2 equals 21 over 5 plus c. Now c equals 2 minus 21 over 5. So this becomes -11 over 5, which is the same as -2.2. So the equation of line L2 becomes y equals mx plus c. M is 7 over 5. X plus c. And c is -2.2 or 11 over 5. Now let me summarize all of this. So you have a line L1 and there was a line parallel to line L1, which was line L2. So that means the line L2 will have the same gradient, and that line L2 was passing through 3, 2. So 3, 2. Now this line L2 passes through 3, 2 and has a y-intercept of -2.2 or -11 over 5. Now let's try another example. Find the equation of the line parallel to 2y equals 4x plus 6 and passes through 0, 5. So you have a line 2y equals 4x plus 6. And there is a line parallel to this, and that line passes through 0, 5. So let's call this line L1. Now, I need to make this line L1 in the form y equals mx plus 3. So what I can do is divide whole equation by 2. So divided by 2, divided by 2, divided by 2. So this becomes y equals 2 1 times 2 2 times 2x plus 2 1 and 2 3. 2x plus 3. Now the gradient of this line is 2, which means that the line parallel to this will also have a gradient of 2. Now let's call the parallel line as L2, and the gradient of L2 is 2, just like the line L1. That means L2 will also have the equation in the form y equals mx plus c, where m equals 2. So this becomes y equals 2x plus c. Now to find out the value of c, I'll use the coordinates 0, 5. So for y, I'll substitute 5, and for x, I'll substitute 0. So 5 equals 2 and 0 plus c. So 2 times 0 is 0. So 5 equals 0 plus c. So c equals 5. So its equation becomes y equals 2x plus 5. Note that the line L2 passes 0, 5, which means that the y-intercept is 5. Y-intercept is the value at which the line intersects the y-axis. So for example, this line intersects at y equals 5. Now at y-axis, all x values are 0. So this point is 0, 5. That means y-intercept is the y value when x equals 0. So I could simply write the y-intercept as 5 when I could see that the line L2 is passing through 0, 5. Now, before starting with the equations of perpendicular line, we need to understand how their gradients work. For example, you have a line having a gradient or a slope of m1, and you have a line perpendicular to it having gradient of m2, and m1 is perpendicular to m2. So the product of m1 and m2 equals -1. That means the gradient of perpendicular lines are negative reciprocal of each other. Now what does that mean? Now for example, m1 equals 3 over 4. So m2 should equal -4 over 3, since the negative reciprocal of 3 over 4 is -4 over 3. And if you multiply 3 over 4 with -4 over 3, you will get -1. Now let's take another example. For example, m1 equals 2, which also means 2 divided by 1. So the negative reciprocal of 2 would be -1 over 2. So m2 will equal -1 over 2. So 2 times -1 over 2 also equals -1. Now lastly, if you have a line with gradient of 6 over 7, so the negative reciprocal of it would be -7 over 6. So the line perpendicular to it will have gradient of -7 over 6, and 6 over 7 times -7 over 6 equals -1. So let's try a perpendicular line question. A is the point 2, 3 and B is the point 7, -5. Find the equation of the line through A that is perpendicular to line AB. So you have a point 2, 3, that is A, And you have another point 7 comma negative 5. And this point is B. And here you have the line AB. Now there is a line through A that is perpendicular to AB. So line through A which is perpendicular to AB. So first we will find out the gradient of the line AB. So MAB equals y2 minus y1 divided by x2 minus x1. So this becomes 3 minus 5 divided by x2 minus x1. So 2 minus 7. So the gradient of line AB equals 3 minus 5, so 3 plus 5, which is 8. And 2 minus 7 is negative 5. So the gradient of line AB becomes negative 8 over 5. Now the gradient of this perpendicular line would be the negative reciprocal of negative 8 over 5. Since the gradient of perpendicular lines are negative reciprocal of each other. So the gradient of perpendicular line, let's call this perpendicular line P. So MP equals 5 over 8 and positive. Now the equation of P becomes y equals mx plus c, where m equals 5 over 8. So this becomes y equals 5 over 8 x plus c. Now we need to find out the y-intercept of P. So I know that P passes through point A, which is 2, 3. So for y, I'll substitute 3. And for x, I'll use 2. So 3 equals 5 over 8 times 2 plus c. 2, 1 and 2, 4. So this becomes 3 equals 5 over 4 plus c. And 3 minus 5 over 4 equals c. So c equals 7 over 4. So the equation of this perpendicular lines become y equals mx plus c. So m is 5 over 8. Y equals m 5 over 8 x plus c, which is 7 over 4. Here we have another very interesting question related to perpendicular lines. So A is the point negative 2, 0 and B is the point 0, 4. Find the equation of perpendicular bisector of AP. So perpendicular bisector is a line segment that bisects another line segment at 90 degrees. So for example, you have a line AB and there is a perpendicular bisector P of AB. So this perpendicular bisector P will bisect the line segment AB into 2 equal parts. So that means the perpendicular bisector needs to pass through the midpoint of AB. Let's call this midpoint M. Now the length AM should equal the length MB and this angle needs to be 90 degrees. So this perpendicular bisector P will bisect the line AB, and to bisect this line, it needs to pass through the midpoint at 90 degrees. Now here you have the point A negative 2, 0 and point B 0, 4. And here is the perpendicular bisector P of line segment AB. So first, you will find out the gradient of the line segment AB. So let's call the gradient of AB as MAB. Gradient is change in y over change in x. That is y2 minus y1 divided by x2 minus x1. So the gradient becomes 4 minus 0 divided by 0 minus minus 2. 0 minus minus 2. So 4 minus 0 is 4 and 0 minus minus 2 is 0 plus 2, that is 2. So 2 1 times 2 2 times. So the gradient of line segment AB equals 2. Now as you have learned, the gradient of perpendicular lines are negative reciprocals of each other. So if the gradient of line segment AB equals 2, then the gradient of P equals the negative reciprocal of 2, that is negative 1 over 2. Now the equation of perpendicular bisector P becomes y equals mx plus c, where m equals negative 1 over 2. Now we need to find out the y-intercept for this perpendicular bisector. In order to find the y-intercept, we need to find out this midpoint M and then substitute coordinates of midpoint for x and y to find out the y-intercept C. Now to find out the midpoint of any line segment, you take the average of x and y values. So midpoint M equals negative 2 plus 0 divided by 2, comma 0 plus 4 divided by 2. So this becomes negative 1, comma 2. Now coming back to the equation of perpendicular bisector, the equation is y equals mx plus c. So this becomes y equals the gradient m of perpendicular bisector, which is negative 1 over 2, x plus c. Now to find out the y-intercept, you will substitute negative 1 comma 2 for x and y. So 2 equals negative 1 over 2 for x, negative 1 plus c. So this becomes 2 equals 1 over 2 plus c. Now 2 minus 1 over 2 equals 3 over 2. So c equals 3 over 2. Now for the equation of perpendicular bisector, you have both the things, the gradient and the y-intercept. So equation of perpendicular bisector becomes y equals negative 1 over 2x plus 3 over 2. Now that's all for today's lecture. Hope you enjoyed the video.